Okay, these notes is just a continuation of the imaginary numbers, the notes that you just took. So now we're moving on to complex numbers. So when adding numbers to I, that's when they become complex numbers. So imaginary numbers are just I. Complex numbers, it has a standard form, A meaning like a regular number, and then plus some type of I. So that's what makes it a complex number now. So for here, for number 7, -5 plus a square root of a -9. Remember, we can't add these. Similar to saying like they're not like terms. We just can't combine them. So -5 stays -5, but we can clean up square root of -9 now by making this into 3i. Now we have it in standard form with our actual number and our imaginary number, and we just made a complex number. So now when adding complex numbers, kind of like terms, add your actual numbers, then add your imaginary numbers. So 4 plus 1 gives us 5, and that's going to be in the front. And then 7i minus 6i is just going to give us I in the end. So 5 plus I is now our complete answer for this complex number. So now most of this, just to review, it has I thrown into it. So now when we have this with a minus in between, remember this minus is basically being distributed to the two parts in that parentheses. So all I did was change the minus sign into a plus and then all the signs after it. So 1 plus a -4 gives us -3. 2i minus 2i cancels out. So we're just left with -3 here. Multiplying or distributing stays the same as before. We're distributing inside of the parentheses here. 4 times -2 is -8. 4 times 3 would be 12, and then we just tag the I with it. So -8 plus 12i. Two sets of parentheses being multiplied together, we are just going to use FOIL. And we are going to have some things to clean up here. So we got a first, 2 times 4 is 8. 2 times 3i would be 6i. -I times 4 minus 4i. And -I plus, or I'm sorry, times a positive 3i would give us a -3i squared. So combine your like terms. 8 plus 2i. And then this minus 3i squared, remember 3i squared can be simplified. I squared is the same thing as -1. So really what we have here, 8 plus 2i minus 3 times a -1. So I'm writing it out step by step. You can bypass some of these parts here. But in the end, you're going to end up being able to add your 8 plus 3. So we get 11 plus 2i. Overall answer, only FOIL. You have a complex number raised to the second power. So if you wanted to, you can write it out and then FOIL it. I'm going to go the route of square double square. So I'm going to square the first, and then put these together, which would make 6i, and then double that into 12i, and then square the last. This squared, 2 squared is 4, and I raised to the second would be I squared. So we have 9 plus 12i plus 4i squared. We have to clean up this 4i squared. So this becomes 9 plus 12i. Remember, I squared is -1. So in the end, we have -4 here. Combine our like terms now. So 5 plus 12i. So go ahead and give number 13 a try. And then I will do it here in a second. So we get our 9 minus 6i plus 6i minus 4i squared when we FOIL here. 6 i's cancel out. 9 minus 4i squared, which is really 9 plus 4, because I squared is the same thing as negative 1. So we get 13. So overall answer. I want you to take a look at 13 and take a look at 11. 11, we got a complex number. 13, we have a regular number here, a real number. That worked out because these are almost the same thing, with these two being opposites, one plus and one minus. These are called conjugates. So you need to note that these two are conjugates of each other, and when they are multiplied together, you get a real number. And that's going to play a big factor in these next types of problems, like number 14 here. Because on the bottom here, we have an I. And remember, I is the same thing as a square root of something. In this case, the square root of negative 1. We cannot have square roots on the bottom. So we need to get rid of that. In order to get rid of that, we need to multiply the top and bottom by something. And remember, whatever you multiply to the bottom, you must do to the top. In order to get this into a real number, we need to multiply top and bottom by its conjugate. So again, conjugate of 1 plus 2i is 1 minus 2i, and we're multiplying that to top and bottom. So this is going to take a bit of work here. Up top, we have to do our FOIL. We're multiplying these two quantities together. So we get 5 minus 10i plus I minus 2i squared. All over, when we are multiplying conjugates, we are foiling, but we don't have to do it because we know the middle parts will cancel out. Just like here in number 13, these cancel out. So all we really need to do is multiply the firsts together, which is 1 times 1. So we get 1. And then the last parts together. 2i times negative 2i, which is a minus 4i squared. So let's clean up the top. 5 minus 9i plus 2 all over 1 plus 4. In this case, it would be 5 here, because remember, I squared is the same thing as negative 1. Look at that. We have the bottom. It has been changed to a real number. And now we just got to continue to clean up the top. So I'm going to write this down here. 5 plus 2 gives us 7 minus 9i all over 5. And this is the same as our original problem. Just looks different. Again, kind of like a dollar bill to 4 quarters. They obviously don't look the same, but they are worth the same. The other thing I want to point out, that the 7 minus 9i all over 5, we should still put this in standard form. So whenever you're taking a top like this and dividing it by the same denominator, in this case 5, we can turn that into 7 over 5 minus 9i over 5. And this is standard form because we have our real number and then our imaginary number. So now we have our complex number in the form it should be, which is basically the standard form. And the last one, if you want to give this a try, pause the video and then I will work it as well here in a second. So we need to multiply top and bottom by the conjugate. So 4 minus 2i is being multiplied to numerator and denominator. The top will need a FOIL. So the top becomes 12 minus 6i minus 36i plus 18i squared. The bottom, we can multiply the front and the back to get 16 minus 4i squared. Clean up the top. 12 minus 42i minus 18. Clean clean up that I squared over 20, because this becomes 16 plus 4. And then clean up the top. So all together it cleans up to negative 6 minus 42i all over 20. Two things to look at is that this can be reduced. First off, they're all even numbers, so we can reduce it into negative 3 minus 21i all over 10, and then we have to take that, write in standard form. Or if you don't recognize that right away and you take this and write it in standard form, negative 6 over 20 minus 42i over 20, so we're starting back here. You can reduce each of these fractions, and in the end you're going to end up with the same thing, negative 3/10 minus 21i over 10. Now it's in standard form, and this is our complex number. So this stuff will take a little bit more practice. Earlier we did adding and subtracting complex numbers, which is a little bit easier, but once we get to this division stuff and cleaning up the denominator, it will get a little tougher, so we will need to work at this.